Hey Algebra 1, today we're going to take a look at how to solve literal equations using the same methods we've seen so far with solving equations, just a little bit of a catch here with literal equations. So how we define literal equations is just like we see on the very top of the screen right here. They are equations with multiple variables, okay? So that's how we basically define what a literal equation is that you have an equation with multiple variables in front of it, or with it, added, subtracted, multiplied, divide with it. And sometimes we have to solve them for a certain variable, okay? So for instance, if we're solving the following equation, x plus y equals 4, for x, all we have to do is basically treat y like it's a number. It could be x plus 3 equals 4, x plus 7 equals 4. Regardless of what number it is, we know that we want to subtract y. We want to subtract it from both sides, okay? So we're going to go ahead and just do that. We're going to subtract y from the left side, subtract y from the right side. Y's are going to cancel like it would any other number, and that means we get y or x equals 4 minus y. And we want to leave it as 4 minus y because they're not like terms. So we can just leave this. When we solve the equation for x, we get x equals 4 minus y. Same thing for the next problem here. It says 2x minus y equals 6. Okay? Like I said before, we want to treat everything else as if it's a number of some kind. It's constant value, like we would for a normal equation. It's just now that y is there, we have to treat it like it's y, obviously. It's unlike x. It's unlike everything else. So we wanted to start by adding y. Okay? Just like if it were 2x minus 4, 2x minus 10, any number there, we want to treat it as if it's just a number. Y's are going to cancel. 6 plus y, we don't know what y is, so we're going to leave it that way. So 6 plus y goes on the right side. All I have left is just 2x. Okay? So just like we saw before, if this 6 plus y, if this were a number, we would want to divide both sides by 2 to get x by itself. But in this case, when we go to divide both sides by 2, we want to divide everything, this whole sum here, by 2. So we're going to put this in parentheses, divide everything by 2. My 2's on the left side are going to cancel. I get x is equal to basically the sum of 6 and y divided by 2. Okay, so that's how we would define the original equation in terms of x. Next example, solve the following equation for x. Okay, so I've got an x on the left side, and I have another x on the left side. And that's all I have on the left side of the equation here. So 2x plus x equals y minus 7. When I have both of the same variable on both sides, I'm going to go ahead and I'm going to combine these. Okay, so 2x plus x, that combines to give me, you guessed it, 3x equals y minus 7. So we want to be able to watch out for the variable that we're solving for, so that way we know if we need to combine any like terms and not get caught up missing out on a variable here. Okay, so next step is going to be just like the last one. We're going to divide by 3, and just like in the last problem, we want to divide everything collectively by 3 on that right side. 3's are going to cancel. I'm left with x is equal to the difference between y and 7 divided by 3. Not y minus 7, like y divided by 3 or 7 divided by 3, but we want to make sure that we're dividing everything by 3. Okay? 3 more examples. All right. Solve for a. Now we have 2 variables here where the variables are on both sides of the equal sign. So we have 3x plus a equals 6a. All right. With this example, we want to designate a side for our variable to be on. Obviously, we're solving for a, so why don't we just go ahead and move the single a here to the right side. The way I'm going to do that is just pretend a is like a number. Okay, it's plus a. That means I have to subtract a from the left side, and subtraction property of equality says I have to subtract it from both sides. Okay, a's cancel on the left side. I'm left with 3x. And then 6a take away 1a. That's going to be 5a. All right. And then, just like any other equation, if I'm trying to get a by itself, I'm going to go ahead and divide by its coefficient. Divide by 5. And 5's cancel on the right side. Nothing's canceled on the left side. Nothing simplifies, so we're just left with a equals 3 times x divided by 5. If we wanted to, we could rewrite it as 3/5 x, it means the same thing, okay? But if you leave it as the first, this is the first one, that's totally acceptable. Okay? All right, this one's a little bit trickier, but nothing we can't handle. Solving for a with the equation a plus b plus c equals 2c plus d minus a. Okay? So once again, we want to identify the variable that we're solving for the whole equation like we did in the last two examples, and we're going to go ahead and we're going to just isolate that variable. So I have one a on the left side and a negative a on the right side. Remember, we want to have as many positives as possible, eliminate the number of negatives that we can. So I'm going to go ahead and start on the right side by eliminating that negative a by adding a to the right side and then adding a to the left side of the equation. When I do that, a's on the left side are going to cancel because negative a plus a is 0. A plus another a gives me 2a. So 2a plus b plus c equals 2c plus d. 4 variables, but now we can go ahead and we can solve this equation now that we have all of our a's to one side. Okay, I'm going to start with the first non-a term, which is b. Because it's plus b, I can treat it like it's a number and subtract b from both sides of the equation. There are no like terms with b here, so I'm just going to go ahead and subtract b off to the right side here so I don't get it confused with any of the terms here. Okay, b's cancel on the left side. I'm left with 2a plus c is equal to 2c plus d minus b. And then my next step is I'm going to subtract c from both sides. Now c does have a like term on the right side, which is 2c, so I'm going to subtract c from there, instead of putting it off to the side in the blank space like I did with b. C's cancel on the left side, 2c take away 1c is another 1c, so c plus d minus b, and then I'm left with 2a on the left side. So now I'm with the equation 2a is equal to c plus d minus b. And just like in the previous problems, we want to go ahead and divide. And when we divide everything collectively on the right side. Okay, 2's cancel, and then a is going to be equal to all this on the right. So c plus d minus b, all divided by 2. Okay, one more example. Solve for a. 2a plus 2b is equal to c plus a. Okay, so once again, the variable I'm solving for is on both sides of the equal sign, therefore I want to move it over where I have the least amount of negatives as possible. And that's going to be moving this a, the single a on the right side over to the left. So I'm going to subtract a and subtract a. A's cancel on the right side, 2a take away 1a is just 1a. So 1a plus 2b is equal to c. Okay, and now, well, we have a plus 2 times a number that we don't know, so this would be just like solving a one-step equation. I'm just going to move that 2b over to the left side, so minus 2b. 2b's cancel, I'm left with a is equal to c minus 2b. And in this case, because there's nothing else in front of the a, there's no coefficient, there's nothing multiplying or dividing here, I'm done. That equation is done. A is equal to c minus 2b. Okay? If you guys have questions, make sure you message me as soon as you possibly can, but your homework for this evening is to complete Delta Math. So if you go to deltamath.com, make sure you do the solving literal equations practice. And there is also a PDF of tonight's homework on our classroom page. Make sure you do all that. I'll see you guys in class later. Have a good one.